This tutorial is about making comparative statements relating to the subsets that you're examining in your sample. So, in this example, we have this box and whiskers plot. And we're going to use this box and whiskers plot and dot plot to make our comparative statements about the question, do boys tend to be taller than girls in the population of high school students in the 2015 New Zealand Census at School database. In that database, there are about 50,000 students in the population, and in this sample you can see there are 38 plus 59, so 87 students altogether. And we're going to use this to make our comparative statements. These comparative statements are important because this is leading you into being able to make the statement about what trends you see happening here and whether those same trends happen in the overall population or not. So, you've identified your population, you've identified your sample, you've identified your quantitative and qualitative variables, you've proposed your questions, which, as I said in this case, is do boys tend to be taller in centimeters than girls in the population in the 2015 in the population of the 2015 Census at School database. And so we're ready to make our first comparative statement. These comparative statements must do the following things. Your statements must compare summary statistics for your two subsets for your sample. That is, what is the difference between the sample statistics? They must be written in context. That is, they must reference the variable and the unit you are using. They must reference the sample only. What you're saying from the summary statistics, it cannot be equated to the population yet. And if possible, whether you would expect that difference to occur. And you divide your statements into central tendencies, mean and median, and the spread. And this should be central averages. Okay, so I'm going to go back to this and we're going to get started. So here's our sample summary statistics. You can see the minimum, lower quartile, median, mean, upper quartile, max, standard deviation, and the number of dots. The first thing to remember about these these box and whiskers is that you have 25% of the data here, another 25% of the data here, 25% of the data here, and 25% of the data there. It's also important to remember that the interquartile range, which is from the lower quartile to the upper quartile, contains 50% of the data, as it does here. So the middle 50% of the girls' data is here between this value and this value, and the middle 50% of the boys' data is from here to here. And that's important. Okay, so the first thing is to start looking at the measure of the central tendency, that is mean and median. And you can see the median for the boys is here and the girls is here. If we look at this, we can see that the median height is 157.5 centimeters for the boys and 158 for the girls. And I can say that the difference between these two medians is 0.5 centimeters, and the girls tend to be very slightly taller if we take the median for this sample. So now I'm going to go and write that statement. So here's, for this for this sample, I notice that the difference in median heights, and this is what we mean writing in context. I've mentioned the variable I'm using for boys and girls is 158 minus, and you must show your evidence. So you can't just put 0.5 centimeters, you must show why. And this is the girls' median and this is the boys' median, with the girls' median height being very slightly to the right of the boys' median height. So we've said this is only for the sample, and we've said that the girls' median is slightly higher than the boys by 0.5 centimeters. That's context, and they must be present. Once we've got that, we can then go back and say the same about the means. So we note that the girls' mean height is 157.97, and the mean height for the boys is 156.68. Which again means the girls' mean is slightly higher than the boys, and is slightly to the right. It's also almost exactly the same as the median there, and there's a little bit of difference there. So we're going to make that statement on means. For this sample, I notice that the difference in mean heights for boys and girls is, so I've mentioned the context, I've got the two means mentioned, and the difference is 129 or 1.29 centimeters, with the girl's height being slightly to the right of the boy's mean height. So there's your context. So we've made comparisons, and what we want to be able to do is build the evidence to say whether these same trends on average heights are occurring back in the population. That's where we want to head eventually. So the next thing we're going to look at is the spread of the data. And the first spread of the data that we're going to look at is the interquartile range. So for the boys, that is 165 here minus 145 here. So that is exactly 20 centimeters. So in a 20 centimeter height range, you've got 50% of your data. For the girls, it's 175 here, and it's 151 for the, so there we have a difference of 24 centimeters. So even though it doesn't look like it, the girls' data is actually slightly more spread out than the girls' data is slightly more spread out than the boys' data, and it's shifted slightly to the right of the boys' data, just slightly. You can see there, and this is definitely shifted to the right here. And so we're going to go and say that now. We're going to make a comment on interquartile range. So I noticed that for this sample, the interquartile range, or middle 50% of the girls' heights, again context, lie between 175 and 150, which is 24 centimeter difference, while the boys' interquartile range lies between 165 minus 145, which equals 20 centimeters. This means that the girls' interquartile range lies upstream from the boys' interquartile range box and is slightly more spread out. Now this statement is really, really important because we will be talking about this in depth. The next thing to note here is that this median for the boys lies entirely within the girls' middle 50%, and this median here lies entirely within that. Now, this is really important. One, there's not much difference between the medians, and two, when the two medians lie inside each other's interquartile range box, there's not much likelihood that there is any difference statistically between these two data sets. It can happen if this median was here and this median was here, but it's very unlikely, and that's something we need to note. So we'll state that this median lies inside that median, and interquartile range box, and this median lies in that interquartile range box. And that's really, really important. That's one of two really crucial pieces of information. So I noticed that the sample boys lies inside the interquartile range. Again, I've mentioned context and units, and I've even restated the interquartile range, and the girl's median height of 158 lies inside that box. That's really very, very important. The next thing that we can look at is the range itself. So that's just the difference between the maximum and minimum. So for the girls, that's 175 minus 125, which is 50 centimeters, and for the boys it's 180 minus 131, which is 49 centimeters. So we can go and state that. So we've stated, I noticed that for the sample, the range of boys' heights is that, and while the range of girls' height is this, 50 centimeters, this means that the girls' data is very slightly more spread out, and that should be the boys' data there. That should be changed to boys. Data. And then the next thing is to go back and notice that in this case, because 50% of the data is from here to there, and 50% of the data is from here to here, and that these two medians are it's below that. You can't even state that this median is, you can't even say that it's 50% of the data lying above 50% of the data. So that, as you see, that median is higher than that median by 0.5, and yet there's a big extension here. So in fact, it's hard to argue that there's any difference in the top 50% and the bottom 50%. So let's go down to here, and I'm going to change this actually. I noticed that for this sample, the top 50% of the girls' data lies, and actually it doesn't lie very slightly above. It lies, if anything, above or below, so very slightly below the bottom 50% of the boys' data. Even more so, it is difficult to state a difference. And I'm just going to go back here and change this to boys. Now, so we've made 6 comparative statements. One about median height, one about the boy means, one about the interquartile range, one about where the medians lie, whether they lie in the interquartile range boxes. We've made one about the range, and we've made one about the top 50%, bottom 50%. We'll be talking more about that later in terms of making calls back in the population. Next video we'll be talking about shift and overlap, which are crucial.